Hi, this is Shannon section in a new chapter, Chapter 6. This is Section 1, Algebraic Expressions and Formulas. On our agenda today is we are going to evaluate algebraic expressions, use mathematical models, understand the vocabulary of algebraic expressions, and simplify algebraic expressions. So first of all, today there are a couple of definitions, that you need to know. First of all, variable. Okay, so a variable is a letter used to represent various numbers. We often think of the variable x or y in our algebraic expressions. Any letter can be used as a variable. An algebraic expression itself is a combination of variables and numbers using the operation of addition, subtraction, multiplication, or division, as well as powers or roots. So here we have several examples of algebraic expressions. X plus 6, x squared minus 6, x times 6, x divided by 6, and then a combination of those last ones that we talked about, 3x plus 5, or the square root of x plus 7. So any of those are great examples of algebraic expressions. Of course, there's millions and millions more. So the first thing you need to know in this chapter really is to know how to evaluate an algebraic expression. In this one we have 7 plus 5 times the quantity of x minus 4 cubed for the value of x equals 6. So really all we are doing is we're taking the value of x and replacing it or substituting 6 in for that and evaluating it. So I'm going to write this out as 7 plus 5, 6 minus 4 to the third power. So if you remember all the rules of PEMDAS, we're going to do everything inside the parentheses before we do anything else. So 7 plus 5 times 6 minus 4, which happens to be 2, to the third power. Now the next part of that rule is we're going to look for exponents, and we have a 3. So 2 to the third power happens to be 8. Then in PEMDAS, the next thing is multiplication or division, working from left to right. We only have a multiplication here, so we're going to do this now. So that would equal 7 plus 40, and now we can finish it up, and it's 47. Now I want you to take a moment to try the next one, stop the video, and turn it back on to see if your answer is correct. So I got an answer of 608. And I hope that's what you got. Now we're going to try this again. We are going to replace the x values here with 6. So I'm going to say, and you know what, lots of times I like to use parentheses because I think of when I remove the variable I have an empty pocket. So the parentheses kind of look like a pocket. I'm going to replace that, put 6 into the pocket. Do the same here. This way we kind of keep things orderly and keep variable numbers separated. So now I'm going to work on an exponent here first. So we have 36 plus, and now 5 times 6 is 30 minus 3. And we're going to work from left to right. So 36 plus 30 is 66 minus 3 is 63. And that's our answer for this one. We can do the same thing for this one, and you'll see why I like the pocket situation a little bit more, because we have two variables here. We have an x of 4 and a y of negative 2. So I'm going to put 4 in. Oh, I forgot my 2 there. I'll put that there. Plus 5 times 4 and negative 2 minus negative 2 to the third power. So see, here we have this 4 and 2. It just keeps things a little bit separated. We have a negative 2 to the third power. We need to not drop that negative. So now let's do exponents first. So we'll have 2 times 16 plus 5 times 4 times negative 2. And then this one, negative 2 to the third power is negative 8. I'm keeping it inside the parentheses because we have a negative. But now we can deal with that negative. A negative and a negative makes it a positive. We can multiply these two things. So this is 2 times 16 is 32, plus 5 times 4 is 20, and 20 times a negative 2 is a negative 40. So we have 32 plus a negative 40 plus 8. So I'm going to actually take 32 and 8 and put them together, and that's 40. 40 minus 40 is 0 in this case. Now, take a moment, try these two on your own, and check your work. Okay, so for the first one, I got a negative 2. And on the second one, I got a negative 56. Now, here's a few more definitions you need to know. You should write them down because you're going to be responsible for these definitions. There's a possible vocabulary quiz before the end of the chapter. The first one is equation. You need to know that an equation is formed when an equal sign is placed between two algebraic expressions. So I can think of two different algebraic expressions, say like x squared minus 3, and then let's say x plus 4. Well, this is not an equation yet until I have an equal sign in between them. A formula is an equation that uses letters to express a relationship between two or more variables. So I can think of a formula that we use all the time in geometry is area, and that is length times width. So that would be an example of a formula. Mathematical modeling. Well, a mathematical model is modeling itself is a process of finding formulas to describe real-world phenomena. So lots of times when we're trying to figure out how to describe something that's happened, we look at variables and then come up with a model. A model breakdown is when that mathematical model gives an estimate that is not a good approximation. So sometimes a mathematical model might work for a certain little bit of frame of time or temperature, say, but then after a while it doesn't work anymore. So if you think about in the winter time, we lay salt down on the roads to protect our road, protect the drivers, and to make ice melt. But at a certain time last winter, we got down below 0 for many, many days, and that salt no longer worked, and it was a breakdown of a model that we've used to help the roads. So that would be an example of a model breakdown. Here we have an example problem from our book. It's mathematical modeling, the amount spent on online dating. So let's read this together. In 2003, 28.5 million U.S. adults browsed internet personals, and 17.4 million posted online personal ads. The bar graph in Figure 6.1 shows the amount spent in the United States in millions of dollars on online dating. I have that bar graph right here, so if you want to take a moment to look at that, there it is. Here, there are 3 mathematical models for the data shown in the graph. In each formula, D represents the amount spent on online dating in millions of dollars X years after 2002. So we have 3 models here, and we want to figure out what model best describes data in 2004. Well, 2004, first of all, is 2 years after 2002. So our X in this case is going to be 2. And what we're going to do is put that value of X into each of these models and to see what the outcome is. So for this first one, I'm going to put 236 times 1.5 to the second power. And what I need to do is put that into my calculator and calculate the outcome for that. I have an outcome of 531. Now let's do the same thing for the next one. We have 127 times 2 plus 239. Let's find our outcome for that one. I have 493. And lastly, I'm going to put 2 in here. I'm just going to write it below it, and I'm going to put this into my calculator. So this will be negative 54 times 2 squared plus 234 times 2 plus 220. I have 472. So what I need to do is look at my model. On the next page I have my bar graph, and we were looking at the year 2004, so that's this one right here, and this one says that our actual outcome was 473. Which one came closest to 473? Well, here it is, 472. So really, our best model in this case is Model 3. We have a few more vocabulary words that you need to know. There's a lot in this section. So first of all, terms. What are terms? Terms are parts of algebraic expressions that are separated by addition and subtraction. So if I gave you an algebraic expression like 3x squared plus 4y minus 3, there are actually 3 different terms here because they're separated by an addition or a subtraction. We also have what is called a coefficient. And in the above expression, we have 3x squared. The coefficient for that is the numerical part of the term. So if you look, the 3 is the coefficient for that part, and the 4 is the coefficient for that term. A constant is a term that is just a number. We have a constant in the above example, and that is this number right here. It's a 3. There is no variable attached to it, so it is the constant. And not only is it a 3, but it's a negative 3 because there's a negative in front of it. Like terms. Terms that have the same variable factors. In the above example, we have no like terms. However, if I were to write something like this, the like terms would be the ones that have the same variable at the same power. So here, 3x and 4x are like terms, and there's something that we can combine to simplify an expression. So if I were to simplify this expression, it would be 3x squared plus x plus 2. Now we're going to actually practice simplifying some algebraic expressions. Here you notice that we have a parentheses and an algebraic expression within the parentheses. We have a 5 on the outside, and we need to use our distributive property to simplify this. So we're going to take that 5 and actually multiply it to 3x and to negative 7. So it'll be 5 times 3x plus 5 times a negative 7. And then this negative 6x is going to remain out here for now. So 5 times 3x is 15x plus a negative 35 minus 6x. Now we would like to combine like terms. Here we have 15x and a negative 6x that we can combine. The negative 35 does not have an x attached to it, so we can't combine it. So 15x minus 6x happens to be 9x, and then we'll just leave that 35 right here. So that is our simplified expression. We need to do the same thing for number 2. We have a 6 that needs to be distributed, and a 10 that also needs to be distributed. 6 times 2x squared plus 6 times 4x, and then 10 times 4x squared plus 10 times 3x. This becomes a 12x squared, 24x. This is 40x squared plus 30x. Now, there's 2 sets of like terms that we can combine. And I'm going to square the ones that go together here and circle the other ones. So I can combine the 12x squared and the 40x squared. So that becomes 52x squared. And I can also combine the 24 and the 30, so that becomes 54x. So my final answer for that one is 52x squared plus 54x. Number 3 is a little bit more complicated because we have two sets of parentheses basically. And I'm going to work from the inside out. Notice that there's a negative here, minus x minus 3. I'm going to put a little 1 in front of that because what that tells me is I need to distribute a negative 1 to both of these numbers. So let's rewrite this as 8x plus 2 times 5, and I'm going to take this negative 1 times x, what makes it a negative 1x, and negative 1 times a negative 3, which makes it a positive 3. Now I can combine like terms inside of this parentheses. So 5 plus 3 is 8. So let's rewrite this. 8 minus 1x. And now I can distribute this 2. So I'll have 8x plus 2 times 8, which is 16, times 2 plus 2 times a negative 1x, which makes it a negative 2x. Look, almost done.
I don't know 6, 8, 9, 10, or 12.
Alright, so now I'm going to add these two like terms. So 8x minus 2x is 6x plus 16. And that is my answer for that one. Now it is your turn to try this. Stop the video and come back and check when you're done. Okay, so our answers for number 1 is 3x minus 21. For number 2, it is 38x squared plus 23x. And for number 3, it's 2x plus 36. That is the end of this video for today.